In this video, let's practice writing some partial fraction decompositions of some proper fractions together. Here's our first example. For this one, we have 3x over this 2x squared minus x minus 1. Alright, first thing we're going to do is take a look at the denominator here and see if we can factor this. So with this quadratic trinomial, we're going to always see if we can factor. So I think I'm going to factor this into the quantity of 2x plus 1 multiplied by the quantity of x minus 1. So now that we factored the denominator, let's go ahead and just rewrite our expression. So we're going to have this 3x on top. And then we have this 2x plus 1 times the quantity of this x minus 1. Alright, so now that we factored the denominator, we want to notice that we have two distinct linear factors on the bottom. So we have one factor of 2x plus 1 and another distinct linear factor or different factor of x minus 1. So let's go ahead and separate this into a sum of two expressions. Alright, so separating this, we're going to go ahead and say we're going to put this variable of a. I'm going to put this a on top of the first expression down there, which is this 2x plus 1. And I'm going to go ahead and add another expression here. I'm going to call this one b and use a different variable. So it's going to be on top of that other linear factor of the x minus 1. So now that we have this equation here, let's see if we can solve for a and b. Alright, so let's get a little bit more space here. So if we take this equation and we multiply both sides by the denominator of this 2x plus 1 times this x minus 1, let's see what's going to happen to both sides of this equation. Multiplying this 2x plus 1 times x minus 1 to the left side of the equation, notice how this 2x plus 1 is going to cancel out and the x minus 1 is also going to cancel out. So on the left side of the equation, we're actually just going to be left with this 3x. Then multiplying this expression by this term over here, the 2x plus 1 and 2x plus 1 are going to cancel out. So we're going to be left with a multiplied by the x minus 1. So let's go ahead and say that the 3x on the left side is going to be equal to a multiplied by that x minus 1 expression. Then finally, if we take this expression and multiply it by this term here, the x minus 1s are going to cancel out and we're going to be left with this b multiplied by the 2x plus 1. So let's go ahead and write that. It's going to be plus. We're going to have this b and then multiply it by that 2x plus 1. Alright, next let's just go ahead and clean this up a little bit. Let's take this a and distribute it and take this b and distribute it as well. If we do that, we're going to get this equation right here. Now let's go ahead and rearrange the right side of this equation a bit. Alright, so the left side of this equation is pretty straightforward, but the right side needs some cleaning up here. So on the left side, we have that 3x, and on the right side, let's go ahead and write the terms that have the x as well. So let's start with saying that we have this ax, and then we're going to go ahead and add on this 2bx. Let's go right plus, and then 2 multiplied by b multiplied by x. So we have all our x terms first here. And then afterwards, let's go ahead and just write our constant terms here. So we have this minus a, and then we have this plus b. Alright, at this point, I think it's going to be useful to go ahead and rewrite our equation so that everything can kind of match and line up. So what I mean by that is on the left side, I'm going to go ahead and actually write this as 3x and then plus 0. So I know it seems kind of silly to write that on the left side, but you'll see what I mean in just a moment. So that's going to be the left side, and the right side here is going to be the same. So why are we setting it up like this? Well, if we look at these two terms together and factor out their GCF of x, we can keep the left side of the equation, and we can rewrite these two as the quantity of this a plus this 2b. That's going to be in parentheses here, and that's going to be multiplied by x, or the GCF of these two terms. And we won't do anything with this minus a plus b yet. So we just rewrote this part of the expression, and then let's see what we're going to do next here. Given that the left side of this equation must equal the right side, I think it's fair to say that this 3x must equal this quantity of a plus 2b multiplied by x. Now if that's true, then this coefficient of 3 has to equal this coefficient of a plus 2b for the x terms. Writing that down, we can say that 3 is going to be equal to this a plus the 2b. Now similarly, the constant of plus 0 that we added on the left has to equal that negative a plus b on the right, which represents constants. So from this, we can write another equation here, and we can say that 0 is going to be equal to this negative a plus b. At this point, hopefully it looks familiar that we have a system of linear equations. We can go ahead and use substitution or elimination. Now, I really like this a and negative a here, so we can go ahead and add these two equations and eliminate the a's. So 3 plus 0 is going to be 3, and on the right side, that 2b plus 1b is going to be 3b. And if we go ahead and divide this equation of 3 is equal to 3b, divide both sides by 3, we're going to see here that b is going to equal 1. So we know b is equal to 1 now, and we can actually solve for a if we substitute the 1 in over here, in for b into this equation, or over here for this one. So totally up to you. If we go ahead and substitute it into the bottom equation here, we're going to get 0 is equal to this negative a, and then we're going to say it's going to be plus 1. We know the value of b now. If we take away 1 from both sides, we're going to say negative 1 is equal to negative a. And then if we go ahead and divide both sides by negative 1 or multiply both sides by negative 1, we're going to get that a is going to equal positive 1. So it's actually the same value as b. Alrighty, so we have the value of a and b, so we can write our partial fraction decomposition now. So let's go back and see what was that original equation we had. Oh, that's right, that was this equation right up top. So if we go ahead and just substitute the values in for a and b that we got here, let's see, we can go ahead and swap out this a and b, and then we know those are just equal to 1. So this would be our partial fraction decomposition. All right, so there is one example. Let's try another one. Let's see what we got. We have a second example here. In this one, we have this expression of this 5x plus 7 on top, and then we have this x cubed plus 2x squared minus x minus 2 on bottom. All right, just like in the last example, let's start by seeing if we can factor this denominator. All right, so we have this cubic polynomial down here, and it has 4 terms. Typically, when we see these, we try to factor by grouping first. So I'm going to go ahead and group the first 2 terms, and I think this is going to work well for factoring by grouping here. So group the first 2 terms here, and then we're going to group the next 2 terms, but let's go ahead and take out this negative 1 here while we're at it. So we're going to go ahead and factor out a negative 1 here, and then if we do that, we're going to have a positive x here, and then we should put a plus 2 instead, right? Because if you distribute that negative 1 into that second grouping, that's going to get you that negative 2 that we started with. Okay, so we're going to factor by grouping here. In the first binomial, we can actually factor out x squared as a GCF. So if we actually factor out x squared in this first part, then I'm going to be left with the quantity of x plus 2, right? And then we're going to have the same thing for the other part. Let's just go ahead and copy that down. It's going to be minus 1 multiplied by the quantity of this x plus 2. All right, just like that. So we just factored by grouping here. All right, so that's the first step here, and notice that we have these matching x plus 2 and x plus 2s, so we can go ahead and factor that out here. If we do that, we can say that we have the quantity of this x plus 2. Let's go ahead and just write that first. And then what are we left with? If we factor that out from both of these, we're going to be left with the quantity of x squared minus 1. And hopefully that looks familiar. So this is a linear factor, so that's done, but this is quadratic. And hopefully we can notice that that's going to be a difference of square pattern. So let's leave this x plus 2 alone, right? And then let's go ahead and factor this x squared minus 1 into the quantity of x plus 1 multiplied by the quantity of x minus 1, just like this. All right, so we just factored that denominator here. So let's see if we can rewrite this expression and so that we have it in this factored form. So in the numerator, let's just copy down that we have this 5x plus 7. And then what about the denominator? It looks like in the denominator, we're going to have this quantity of this x plus 2 multiplied by the quantity of x plus 1. And then we're going to have this quantity of x minus 1. All right, that's the entire thing on the bottom. All right, so we have these 3 distinct linear pairs on the bottom. These are the 3 that we have. So when we do our partial fraction decomposition, let's go ahead and just set this up. So we have a over our first distinct linear factor. That's going to be over this x plus 2. And then we can go ahead and add another one. So let's put b. I'm going to go ahead and add b, and that's going to be over this x plus 1 factor. And then we're going to have a third one here and say it's going to be plus. Let's go ahead and add c here, and that's going to be over this x minus 1. All right, so this right here is going to be our equation that's going to help us find our partial fraction decomposition. All right, let's go ahead and take that equation now and see what we can do with it. Okay, so here is our equation. And to get rid of the denominators, what we're going to do here is let's go ahead and see if we can multiply everything by the LCD, or least common denominator. All right, in this problem, that least common denominator is just going to be the denominator of the left side there. So let's go ahead and do that. So if we go ahead and multiply both sides by that denominator, if we multiply this by this term over here, the x plus 2 and x plus 2 will cancel, x plus 1, x plus 1, x minus 1, x minus 1, and we're going to be left with this 5x plus 7 on the left side. So let's go ahead and write 5x plus 7. That's definitely a little bit easier to write. And then what's going to be next? Well, if we take this and then multiply it by this term over here, the x plus 2's are going to cancel out, right? So we're just going to be left with a multiplied by the rest of that there. So if the x plus 2's cancel out, we're going to be having still this x plus 1 multiplied by x minus 1. And then if we multiply this on the outside by this term with the b, the x plus 1's are actually going to cancel out. So we're going to be left with what? We're going to have plus b multiplied by those two linear binomials that didn't cancel out. I think we're going to still have this x plus 2 multiplied by the x minus 1. Then we have a little bit more to do here, so I think we still have one more. So multiplying this by this term over here, the x minus 1's are going to cancel out, so we're going to have a c left. So let's go ahead and write we have plus c. I think I'm going to run out of space here, so let's go ahead and move this over to the left a little bit here. All right, that looks good. And let's go ahead and multiply that by this x plus 2 multiplied by x plus 1. All right, now the left side is pretty straightforward, so let's go ahead and just work on the right side here. On the right side, we're going to leave this a alone for now, and let's go ahead and take this x plus 1 times x minus 1. Let's go ahead and FOIL that out. That's going to turn into x squared, and it's actually going to become minus 1 because it's a difference of squares. Okay, let's go ahead and then add b here, b, and let's go ahead and do the same thing. So it's going to take b and multiply it by whatever this is factored out here. So I think if we factor this, we're going to get x squared, and then we're going to have minus x plus 2x. It's going to be plus x, and then minus 2. All right, then we have this plus c, and then c is going to multiply by whatever this is FOILed out. So if we FOIL that, that's going to be x squared, and then x times 1 is x plus 2x. That's going to be plus 3x. And then 2 times 1 is going to be plus 2. All right, so this is what that's going to look like. All right, we're going to keep the left side the same again. Let's go ahead and distribute this a to both terms, this b to all 3 of these terms, and the c to all 3 of these terms. All right, so now that we distributed, let's go ahead and organize the right side a little bit in terms of their degrees. So on the left side, we still have this 5x plus 7. And then on the right side, if we go ahead and rearrange and write all these terms together that have this x squared, we're going to get these 3 terms here. And then we can go ahead and write these 2 terms that have x in them. And then let's go ahead and combine these last 3 terms that don't have any x's in them that represent the constants. All right, now everything is organized based on their degree. On the left side of this equation, let's actually go ahead and write a new term in here just so we can keep things nice and organized. So I'm actually going to go ahead and write on the left side that we're going to have this 0 x to the second power here, and you're going to see why in just a moment. And then let's go ahead and write this plus 5x. We're going to keep that the same. So 5 times x, and then keep the plus 7. Now what about the right side? Why did we reorganize everything so specifically? Well, if we look at these 3 terms here with the x squared, we have 3 terms and they all have x squared, so x squared is the GCF, right? So we can go ahead and factor out that x squared as the GCF, and we can just write that we have a plus this b plus this c. That's going to be all inside this parentheses. We're going to factor all of those and leave them alone, and then we're going to have this x squared that was their GCF that we factored out from all 3 terms. Next, we're going to look at these 2 terms that have x in them, and we're going to factor out x as the GCF from both of these terms. So if we go ahead and do that and factor out the x, we're going to be left with just a b here, and we're going to be writing plus 3c. Okay, so we're going to go ahead and factor out the x, so the x is going to be hanging out over here on the outside. So we're just basically reverse distributive property using the factoring of the GCF. And then finally we have our constant, which we don't really have to do much with. We're just going to copy down and say minus this a, and then minus this 2 times b, or 2b, and then plus this 2c. Alrighty, so everything is organized in terms of their terms now and the degrees, so let's see how this can help us. Let's take a look at these first 2 terms that have the degree of 2, or has that x squared. And so while the x squareds already match, our coefficients must also match. So we can go ahead and write this equation of saying 0 is going to be equal to this a plus b plus c, right? Those three variables a plus b plus c must be equal to 0 since we don't have any x squareds in this problem. So we should know that 0 should be equal to this a plus b plus c. Now what about the x term? Well, the x terms must match as well, so the x's already match. And so that means the coefficients must also match here. So what's the equation we're going to write? This 5 on the left side should be equal to this b plus this 3c. So b plus and then 3 multiplied by c. This is a second equation that we can write here. Finally, this constant of 7 on the left side has to equal all the constants on the right side. And so we can go ahead and write this equation of 7 is going to be equal to this negative a. And then we're going to go ahead and write minus 2b. And then plus 2c. All right, so right here we have a system of equations, and this system can be solved if we go ahead and use some combinations of elimination and substitution to find the values of a, b, and c. And we make sense, hopefully, that we have 3 equations here for 3 variables that we're going to solve for. We should really like this equation in the middle because it only has 2 variables. It only has b and c. So maybe we can use the combination of the top equation and the third equation, so this one and this one here, and eliminate a from them. So we can go ahead and eliminate a, then we'll have another equation that just has b and c, and then use those as a system, right? So if we go ahead and rewrite here, here's that top equation, and here's that bottom equation. If we go ahead, it's actually quite nice that we can go ahead and use elimination. Adding these 2 equations together, 0 plus 7 is going to be 7. That's going to be equal to, and then a plus negative a are going to be eliminated. Then we have this b minus this 2b, or b plus negative 2b. That's going to be equal to a negative b. And then we have c plus this 2c, so that's going to be plus 3c. All right, so this is another equation here that just has 2 variables of b and c. All right, so let's go ahead and take this equation here that has b and c with this equation here that has b and c and use those as a system. All right, here is one of them, and here's the other, and let's go ahead and use elimination, and we can actually eliminate the b's quite nicely right away, or the c's, totally up to you. I think I'm going to go ahead and eliminate the b's by adding these 2 equations. If you wanted to eliminate the c's, you could just subtract the 2 equations, up to you though. So on the left side, 5 plus 7, that's going to be 12. And then the b plus negative b are going to get eliminated. Then 3c plus 3c is going to be 6c on the right side of the equation. If we go ahead and divide both sides by 6, we're going to say c is going to be equal to 2. All right, now we have what c is equal to. Let's go ahead and substitute it into one of our equations that has just c and b in it so that we can figure out whatever b is. So I'm actually going to substitute it in right over here. If we go ahead and do that, let's see, I'm going to have 5 is equal to this b, and it's going to be plus 3 times what? I think we said c was 2, so we're going to multiply that by 2. So 3 times 2, that's going to be equal to 6. So we have 5 is going to be equal to this b, and then plus 6. And then if we go ahead and take away 6 from both sides, we should see here that b is going to be equal to negative 1. All right, now that we have b and c, let's go ahead and take the b value and the c value and plug it into one of our equations that has a, b, and c, maybe this one right over here, so that we can figure out what a is. So let's take b and substitute it here, and take c and substitute it right over here. If we go ahead and do that, we're going to have 0 is equal to a plus b, which we know b is going to be negative 1, so it's going to be plus negative 1 or just minus 1 here, and then plus c, which we know is 2, so it's going to be plus 2. Now negative 1 plus 2 is 1, so we know 0 is going to be equal to a and then plus 1. And take away 1 from both sides, we can see here that a is going to be equal to negative 1. All right, so finally we have a, b, and c, so let's go ahead and plug those back into our equation, and then we should have our partial fraction decomposition. So let's go ahead and see what our original equation was at the top here. This was our original equation. So let's go ahead and take this. And if we go ahead and write that equation, just copy that down right over here with our newfound a, b, and c values here, we can go ahead and take out this a, b, and c and replace them with a negative 1. That's a, b is going to be negative 1, and c is going to be a positive 2. And just in case you wanted to write it in a different way, you could write it like this as well, where we just move some of our negatives down to the front of the fractions. All right, so there you have two different examples where we went ahead and did some partial fraction decomposition with some expressions that had some distinct linear factors. If you found the video helpful, please consider giving it a thumbs up and sharing with a classmate or friend who might also find it helpful. And as always, keep up the great work that you're already doing, and I'll see you in the next one.